In free fall, when an object goes up to its highest point and then comes back down, such as a rocket, there's a few things that are interesting to note about this type of motion. The first thing, as I pointed here in number 1, that at equal heights in its trajectory, let me just actually draw these as lines. Let's make this a little bit thicker here. So at equal heights in its trajectory, the velocities are equal, but in opposite direction. And so let's go back here. Suppose that the rocket shot up with a velocity of 30 meters per second. It's positive because that's upward. Well, when it comes back down to an equal height, so when it goes and lands on the ground, it will be an equal velocity, but in the opposite direction. So we could write it like that, or we could write it with a negative. Okay. Let's keep going here. So as the rocket is moving up in its trajectory, it's going to be slowing down because of gravity. Gravity will take away 10 meters per second every second that it's traveling. So let's suppose that a second passes to the next point here. This would be going 20 meters per second. And another second passes. You're going to subtract 10 from that. And another second passes. That's when the rocket is at its highest point, its maximum height, we say. And so let's fix this. Say 10. At its maximum height, this will always be true that the vertical velocity is 0, which we pointed out in part 2 here. So at the highest point, v is equal to 0, right there. And this is true for this type of motion, for all objects for this type of motion. As it falls back down, it will gain speed. Because of gravity, it is going to gain 10 meters per second squared downward. Another second later, it will gain 10 meters per second of speed. In addition to that, some negative 20 as it falls back down. Cool. The last thing we will say here is if this rocket, let's say this rocket is in the air total for a total time of 8 seconds, let's just suppose, then it takes 4 seconds to get to the highest point. But let's write that more generally. So however much time it takes for it to go all through its motion, it takes t over 2, in other words, half, to get to the highest point up right here. That's what I said in part 3. So that's very useful to us. We'll just do one quick example. We launched a rocket in class, and we've done this many times, but the time we get when we launched it in class, let's just use a simple number, rounding here, but one time we had a total air flight of 5 seconds. That means that the rocket went up into the air and it came back down, and that took a total time of 5 seconds. This problem is saying an air rocket launches from the ground and reaches its maximum height. So technically the picture is a little bit different from this one. Here's the rocket. It travels up and it gets to its highest point. So how much time did this rocket take to get to its highest point? Well, we just talked about that. It's half of the total time, so this should be 2.5 seconds. I'm going to have to call them back. Okay, so I don't know if you heard the phone go off. So let's write this here. The rocket in this picture right here, and let's erase this other picture. We don't need this anymore. It starts from 0 height, and it goes to its maximum height, which is going to be y. So this is y naught. The maximum height will be y, some height at a later time. Its initial velocity we don't know, but we do know its velocity up here, right? At the highest point. We said that the velocity is 0. So we'll put a 0 there. Acceleration of gravity, negative 10 meters per second squared. and the time it took was 2.5 seconds. They want to know what is the initial velocity, the starting speed of that rocket, which we don't know, but we can calculate it. We need an equation for V naught, but the equation must be missing y. You can't have y in the equation. That leaves out this equation, and that leaves out this equation. Your only option is to use equation 1. And it does have V naught in the equation. So V is 0. Actually, let me do it this way. V is 0. Now, a lot of people want to cross this out because we don't know it, but you can't cross it out. There is a number that goes there. We just don't know what that number is. So we keep it. Acceleration is -10, and the time is 2.5 seconds. Oops. So you get this. We're going to simplify this. -10 times 2.5 is -25. So we have 0 equals V naught minus 25. Add 25 to both sides. And so 25 meters per second positive equals V naught, or in other words, 25 meters per second upward is the initial velocity. Which makes sense. The rocket should be moving upward at the beginning. For part B, now we just want to figure out what is y. You can put 25 here if you want. We have a very convenient equation for y. It has all the variables we need, and we don't need to exclude anything because we have all the numbers except y. So it's very convenient for us. V naught t. Y is what we're looking for. Y naught is 0. So let me write it like this instead. So we don't have to write it. V naught is 25. Time is 2.5. 1/2. -10. And 2.5 squared. Let's type this in the calculator. I get a maximum height of 31.25 meters. It's something like 100 feet, like over 100 feet. And that is free fall with air rockets.